Okay, so real quick, we'll get started in a minute, but I know there's probably some people that are a couple of minutes late. How's everyone feeling on functions? Do you feel like we need to do some more review? Does everyone, show of hands, how many people feel like 95% or better? Like you feel pretty confident on functions? Show of hands. Is there anybody who'd like maybe a little bit more review on functions? You don't have to feel bad. I can do one more example. Would that help anybody? Or okay, one more? Okay. Okay, so we'll do that. And then I'm going to go over a bunch of random topics today. It's tough because I can't obviously give you assignments on everything, or you're just going to spend all day doing assignments. There are a bunch of like random topics that you'd use in the real world, but I don't want to give you, 35 assignments. I kind of just want to pick the most important things. And so every once in a while we'll have these lectures where it's just like I just kind of give you a random piece of information. Just because I don't give you an assignment on something doesn't mean that it's not important and it's not used constantly. It's just that like, let me think how to say this. It's not such a core concept that it warrants its own assignment. Does that make sense? So we're going to go over a few of those. Like today I want to go over what are sets. I'm kind of iffy. I don't know if I want to do this one or not, actually. How many people, like in high school or something like that, you do Venn diagrams? How many people saw those? So when I use terms like intersection and union, you know what those are? So if I had, I don't want to get out the tablet, but yeah. So and some of you might have taken a class in high school called like discrete math or something like that, where you had to do a little bit of set theory. Mathematically, in Python, sets aren't used a lot, but I've had several instances where they actually can kind of be useful. If I have, well, we'll go over it. We'll start off with a function example, I guess. I don't want to wait too long. Let's just go ahead and get started. So assignment-wise, number 4 is due today, but I think most people already finished it. Show of hands, how many people already finished assignment number 4? Okay, so pretty much almost everybody. What else? So we're still recording. Next week, we're going to do the review for the exam. I'm not going to put out a new assignment just yet. I got to think the direction I want to go. The next assignment's most likely going to be dictionaries, because dictionaries and lists are really important, and you're going to use them together, especially in this modern age where we use this data structure called JSON, or not a structure so much, it's a format. It's called JavaScript Object Notation. And because Python on the server side has become really, really important, and it also is important for consuming web APIs, and JSON's kind of become like the standard of the web. XML was pretty dominant for a long time, but XML is very verbose, and I don't want to get into it. But anyway, this data format called JSON is very popular, and it maps very closely to dictionaries and lists. So to me, that's important enough that you'll get your own separate assignment on that. But we'll worry about that on Monday, and we'll start reviewing on Monday. And then the exam will be on the 16th, so we'll see. Maybe I'll wait until after the exam to give you the assignment, but only give you a week to complete it or something like that. Or maybe I'll assign it on Monday, but give you 2 weeks. But we'll worry about that when we get there. Okay. So let's do one more example. Any questions on administrative stuff before we get started? Yeah. Also, everyone knows how to do things. Access the lecture videos, correct? The other thing is that if, so these lecture videos actually upload immediately, but sometimes I can, especially if it's in the morning and I've got a class full or a day full of classes like today, where, almost immediately after this I have another class to teach. So we're all probably going to get it, so let's just wait a minute. But these upload immediately. All I do is rename them and put them in a playlist. But if you click name, it'll show all the recent videos it might be, you might have to click a couple things because it'll just say like live stream or something generic like that. But if it's been a day and I haven't renamed it, first of all, email me. But if I haven't answered, you can always do that. So don't think that just because I haven't renamed the video, it's not available, because it is available. And we talked about this video series from Microsoft, but in my opinion, I don't know if this is any better than the stuff out there, but I guess being from Microsoft gives it a little bit of weight. It's definitely professionally produced and thought out, so it's not like let me say this, I don't think you're going to get wrong information in there. Sometimes some of these YouTube personalities, they'll give you wrong information, but they're still popular for some reason. But at the very least, I can say that you're probably not going to get wrong or incorrect information from Microsoft. So I threw that in there as an announcement if anybody's interested. It's almost like with Python and some of these other languages, the problem isn't finding resources, it's that you get overwhelmed by them. There's just too many sites, there's too much stuff out there, and you just want to know a good resource that you can just go to, But anyway, so let's go ahead and let's go ahead and open up REPL. So there's already a function in Python for reversing lists. It's just called, it's either reverse or reversed. Hold on. Okay, so it's reversed. But let's make our own version of that. And if you remember, the idea of a function is that we think of it as this box. We pass it in some values, it does some stuff, it gives us a result. Now, sometimes we don't want to we don't even need to get a result. Sometimes it just does some stuff. Sometimes we don't give it anything. Like in the case of if we want to print a very long menu or give a copyright notice or something like that, some very big long block of text that you don't want to put in the middle of your program, you can just make some function just called print menu or something like that. Okay. But for the most part, generally we want to make functions that are like that, make them reusable. Trying to think if I'm missing anything. Just as a quick review, the basic idea of a function is that it's a reusable piece of code. You may write that code or somebody else may write it. In the case that you wrote it, a lot of times it's reusable code. And the advantage of that is if I've got some algorithm and I use that in 15 different places in my program, if there's a mistake or for example, I forget to check for negative values or something like that, I've got to change that in 15 different spots. In very large programs, that becomes very error prone. So there's that advantage because then you'd only have to change it in one spot. It also, just even if you have a function that you only use once, from just a code organization point, it becomes much, much easier to read programs that are function names than read very, very complex details. Okay, so it's this idea of the top-down view of your program, that if you look at it from the top, this is how we use computers, by the way. We don't use computers, we don't start flipping switches and using ones and zeros. We abstract things away. Same thing here is that we don't want to worry about the low-level detail of logic, that we want to abstract it away into functions to where it becomes a little bit easier to comprehend. And then the last use of functions is that oftentimes there's something that's maybe like in the case of an API, either it's something too complicated for you to understand or maybe you're even restricted. Like say, for example, the Twitter API, they're just not going to give you full access to their database. They're going to give you a set of functions that you can use, what's called an API. But what I like to use is the drone example, that I might have a function called go to coords or go to coordinates or something like that, and I pass it a latitude and longitude. There might be a million different things that have to happen inside that function that it's very complicated, like engineering levels, electrical engineering level stuff, like checking for motor status and just a million different things. That's probably too complicated for most people, but the end result is that you just get a function called go to coordinate or go to GPS, and it handles all those things for you. You don't need to know the inside details. But anyway, so enough of that. I'm trying to be good about time. Let's go ahead and create a function. And because the word reversed is already used, it's a reserved keyword, let's just go, we'll do the shortened version, rev, short for reverse. Now, just like with an if statement or a for loop, this is a block, so we indent. And how do we know what thing gives it away already that it's a function? What keyword? What do we start all of our keywords with? What's that? Def, perfect. So in other languages where we have a return type here we just write def. That means that we're dealing with a function. Here we name the function. I decided to call it rev just because there's already another reverse function. I don't want to have namespace clashes or anything like that. So we're just going to call it rev. And then here's where we define our inputs. And so here we're going to take in a list. And the idea is that we're going to reverse the list. Now, just a quick note. This is more of a design principle than anything. In general, it's bad to put input and output statements inside of your functions. So I'll say that again. What's called I/O, input and output, in general, it tends to be very bad to do that inside of functions. With the one exception, if that's the whole function's purpose, then it's generally okay. So let me give you an example of that. Imagine if I have like a sine or cosine or tangent or something like that, some trigonometric function. Imagine within that function, I wrote that function, and the very first line of code was I asked the user for some angle. I had some input statement. And then rather than returning a value at the end, I had a print statement. If somebody wanted to use that function, say for example inside of their video game, inside of their physics engine, bless you, that'd be kind of a useless function because they don't want to, in the middle of the game, start asking users for angles and stuff like that. It's got to be reusable. A lot of, to where somebody can use it, take that value and put it to something else. So when you start putting print statements and input statements inside of your function, you've kind of violated the principle of making it reusable. Now there is one exception that if that's the whole function's purpose is to get input or output, then that's okay. But a lot of people do this. Like they'll make functions and they're writing a program that's say geared toward. So let's take a step back. A lot of during the 70s and 80s, we had all these different computer systems with accounting software. And they were kind of that green screen terminal type, And what they did is they mixed the actual accounting logic with the user input logic. Does that make sense? So they might have a function that depended on me sitting in front of a green screen terminal. And then had a bunch of complicated, what we call business logic, that's very specific to that business or accounting or tax law or something like that. Well, now all of a sudden, in the 90s, we have the web. 90% of that logic, or actually maybe all of that logic, is still good, but what's the one thing that kind of caused problems for us that we can't reuse that code? Exactly. We've got a website, we've got a web page, and we've depended on a terminal. And the way we get input and output from a terminal is very different than the way we get an input and output from a web page. So what do we get in the mid-2000s that, that say, for example, you did the same thing on the web? We started to get mobile apps. Mobile apps tend to use things like web services and other interfaces like that. And now all of a sudden, you could potentially have 3 different systems. And it's like, if you had just written a proper function in the first place with the business logic, the core logic of it, you could have reused that same thing over the period of potentially 40 years, if the actual business logic of that problem hasn't changed. But if you write your software incorrectly and you just kind of write it to where it's very dependent on the interface that you're using, then it's very easy to make your software fragile. Okay. So long story short, leave input and output out of functions as much as possible. So there's already a built-in function for this, but what we can do is, if you remember, we can do this. So we can say for I in there's a special function. Did we talk about range? Let's just do a quick review. And just, I'm going to immediately violate this principle. I'm going to take these print statements out, but we're just going to treat it kind of as a debugging thing. Okay, and then make sure, by the way, make sure that your cursor is all the way over. I don't really like REPL because they use 2 spaces. Let me set it to 4. How do I save this? Does anybody see? Did it do automatic? No, it's still 2. Does anybody see a save button? Oh well, whatever. Okay, so just make sure that it's lined up all the way on the left because we're outside of that function. And I'm going to call it with, let's just hard codes. Well, we'll say that x is equal to, and then we'll just put in some random values. Okay. So what this range function does is it gives us back basically a list of numbers. It's something more complicated called a generator, but essentially it gives us back a list of numbers in order. So here we said range 5, so we went 0, 1, 2, 3, 4. But we don't want to hard code the number 5. How can we find the length of the list to where we don't have to change it each time, where we can, the length of the list can change and we don't have to actually change this function at all? Does anybody remember the name of the function? Yeah, len, short for length. So now this returns a number. I realize that for some people this might be a little bit difficult to read when we start kind of embedding other functions in here. But the basic idea is that we call this length function on my list. Well, the list is 1, 2, 3, 4. So this will return 4. Let's just do this. The 67 is confusing. This will return 4. And then so that'll give me 0, 1, 2, 3. Right? Because we started counting from 0, but that's 4 things. But it started counting from 0, so it goes 0, 1, 2, 3. And now if I added another, or subtracted something here, it would just go 0, 1, 2. So you get the idea. Now if you remember, with lists, just like arrays in other languages, we can use that square bracket notation. So I can do this. Oops, not my SQL, my list. I've been working with databases too much lately. And I can print each element of the list. Now, the range function is actually really cool because we can do a bunch of different things with it. So let's look at its documentation. So if we look here, we've got range, start, stop, and step. Now I'm just going to, you don't have to do this. I just want to do some quick experiments on using this range function. So let's just make a quick list off to the side here. And then print, we have to constitute range. There's one parenthesis here at the end. Perfect. Okay. So let's look at this. We've got start, Well, by default, it starts at 0. That's fine. Stop. We've already passed the stop. We want to see by calling the length of the list. But the step, by default, it's steps one thing at a time. Let's experiment with that. So again, you don't have to type this because I'm going to condense this and then we're going to go back to our example. By default, it steps one at a time. So let's just fill in the default just to make sure that still works. Hold on. Oh, sorry. I think if we use it, we have to specify that it's starting at 0. So let's do 0, comma. Oh. Slow down for a second. I'm trying to talk too fast and do too many things. Okay. Range, 0, length of the list, one step at a time. There we go. Okay. So now let's see what happens when we change this to 2. Okay, that's interesting. So it stepped every 2. So it went 0, it skipped over 1, 2, skipped over 3. Let's see what happens when we use negative numbers. So it didn't print anything, but what if we did this? What if we started at the length, we wanted to end at 0, and then we wanted to subtract 1 each time through? So we're almost there, but we don't necessarily want 4, 3, 2, 1, 0. What do we want instead?
The array elements.
So not so much the array elements. If I was counting, normally I'd go 0, 1, 2, 3. But I have 4, 3, 2, 1. How could I go 3, 2, 1, 0? What do you think I could do?
You want to reverse it somehow?
So not so much reverse. So right now I have 4, 3, 2, 1. What I want instead is 3, 2, 1, 0. How could I offset that by 1? So what we can actually do is, rather than starting at the length, instead of starting at 4, subtract 1, and now I'm starting at 3. And then I don't want to go down to 0. I want to go down to -1. Okay. And let's do this. Because this gets so complicated here, let's do this. Let's simplify. So we'll say start is going to equal the length of the list minus 1. Our stop condition is going to equal -1. And then now we can really clean this up. We can just say go from the starting point to the stopping point -1 at a time. Does that make sense to everyone? So what we've done is we're saying, okay, well, rather than normally we start from 0 and we count up, but here we're saying start from 4, or whatever the number is, in this case 3, and then count down. But if you saw, we have like an offset by 1 problem, and so we need to shift it over by 1. And so what I did is I said, okay, subtract 1 here, subtract 1 here, and it shifts it over by 1, and then we get what we need to. So I'm just going to, just very quickly, just to show you, we have I. So it's going to go 2, 1, 0. Perfect. 2, 1, 0. So now the problem is that we want to return something at the end. This just printing to the screen isn't super useful. So what we have to do is let's go ahead and make a list called result, and let's make it empty. And then let's keep on appending each time through. So we'll do result.append, and then we're going to we're going to append that to the result, and then return the result. Maybe I should have chosen a simpler example. I like to reuse the examples over and over again each semester because I know what works and doesn't work. This one I just made up just to have another example. This one I realized it turned out a little bit complicated. But do you understand the basic logic? Is that we have this special... So first of all, let's take a step all the way back. Is that when I have a list, I can use that square bracket notation, just like with an array in another language. And I can put a number in there. Our numbering system starts from 0 and it goes all the way up to the number of elements minus 1. So we have that square bracket notation. And so anytime I want to get some element of the list, I just do my list and then square bracket that. Well, we can loop through this one at a time. And we use a special function called range. And what that does is that gives us back a bunch of numbers. So normally it would give us back like 0, 1, 2, 3, 5, 0, 1, 2, 3, 4, 5, 6, 7, and so on. Basically however many numbers we need. And we've done that before. But now we wanted to do the opposite. And we looked up this range function. We said, we can actually do other interesting things with it. Rather than go in ascending order, what I can do is I can specify to start from a higher number, stop at a lower number, and then minus 1, go the other direction. So rather than going 0, 1, 2, 3, 4, 5, 6, 7, I can go 7, 6, 5, 4, 3, 2, 1, 0. I can go the other direction. And that's what we've done here. So here we decided that we're going to go the other direction. We're going to decrement. We're going to count down by 1. I is going to take that value each time. So I is going to go 2, 1, 0. So it's going to be my list 2, my list 1, my list 0. And don't forget we had to shift this over by 1 because we were off by 1. And we were printing the result, but that's not really that useful because remember, functions, we want to be able to reuse these things. If I just print it to a screen, what happens if I make a reverse function and I put it inside of a car somewhere, like in its fuel injection system? Probably wouldn't write that in Python, but you get the idea. You can't depend on just a plain old terminal like this. And then we returned that. And at the end, we went ahead and tested this, and it worked. Okay? Any questions on this? Hope that wasn't overly complicated. But it's good every once in a while to get somewhat of a comprehensive example and not just have these little tiny examples out of context. Yeah?
On a sort of unrelated note, if you were to do exactly what you just did, but with strings, how would you get the print statement to print it like a string?
It's actually really good you brought that up. So so first of all, before I move on, does everyone have this copied down and working? Is there anybody who needs help, like you got stuck on a certain part or something? Everyone feels good so far? Okay. So let's get a little bit of extra mileage out of this example. One of the interesting things with strings is that we can treat a string, so I'm going to very briefly, I'm just going to comment this out for a second. One of the interesting things with strings, and this is actually true in C++ as well, is that it's actually an array of characters. So this is actually subscriptable. What I can do here is I can do S0. What do you think that'll print?
H.
Yep, exactly. It'll just give me the H. So it turns out that a string is actually just a list of characters with some extra stuff because strings are complicated. There's other languages, obviously, besides English, and there's other encodings, like there's UTF, 8, 16, 32, ASCII, all these other encodings. And so strings are a little bit more complicated than that, but they're essentially just a list of characters. So what we can do, if we wanted to reverse that string, we can actually treat it like a list. And that actually gave us, as a list, the individual characters. There's a way to join that back together. I don't want to get overly complicated. We might be able to just call it a string function. Let's try that.
No.
You already tried it?
Yeah.
Okay. I don't want to get into this because it's kind of complicated. There's a function called join where we can join a list together. I don't want to get into that. You can look that up. If anybody has time and you want to look how to put that back together, there's a function called join, and that'll join a list back together, okay, into a string. But anyway, you get the idea. So this logic right here is maybe a little bit complicated. It turns out we can actually condense this a little bit more. There are these things called list comprehensions. And the way it works is that you've got some list, and it's got kind of a funny syntax. All right, let's not use X. Let's call this, and you don't have to copy this down because we're going to try it on the other tab. So we're going to say my list equals. Now these are, again, what's called syntactic sugar. It's literally the exact same thing as this. It's just much more condensed. It's what we call, it's the Pythonic way of doing things. It's like what a Python programmer would typically do. And what's cool about this is, let's say, for example, result is equal to this. And so this little code in here will return a list. And let's just print it, print result. Okay, so you can see nothing essentially happened. What it does is it loops through this list. So we say for X in list. And what's going to happen is each time through the list, you've already seen this syntax before, right? For X and thing. In this case, it's for I and range. But you've seen this before. This is kind of a funny little arrangement of it, but you've seen that before. And what it's going to do is each time through, it's going to return the value of X. Well, what's cool about this is we can do certain things to X. Let's say, for example, we talked about this before, right? How to does anybody remember the power operator? What was that? We talked about that last time, right? Let's stay simple. We'll just say if we just wanted twice the amount of X, we do 2 star X, and that'll multiply everything by 2. So this is a much, much more compact way of representing that. Just to be complete, I know I kind of started down this path, but if we wanted to square it, this is how to do a power. So this is going to be X squared, and it's going to square everything through here. So if we wanted to, what I'm going to do is, just so you have both, I'm going to make a second version called rev2. And we're going to use the list comprehension example. And we can actually condense this all down to a single line. And because it's so compact, we don't even need to make a result variable. We can just literally do this. So we're going to, just like before, we're going to have our for I in range. And that's going to give us in reverse order. And then what I want to return is each individual thing. And so we're able to considerably compact that. Oh, so just to be complete, let's call rev and then rev2 and make sure that they give us both the same output. Now, I'm not going to give you an assignment on list comprehensions, but they're very useful in Python, so you might see me use them every once in a while. The basic idea is that it's like our for loop for I in range, that thing we already did. And then each time, each iteration through that loop, it's going to return whatever is here. And then it's going to package that all together into a list. And that's why we put these square brackets, is that we're saying, okay, we want to take all that and put it in a list. But looking at it, just like by itself, it might seem complicated, but it's really not, because we've already done this. right? We already did this before. And then now what we're doing is that, okay, each time through the loop, return the ith element of my list. And at the end, package it all together into a big list. But I think that's as far as I want to take that example. I realize it might have gotten a little bit complicated. But again, it's good to see some of this, real world stuff rather than just very simple isolated things. Okay, any questions on this before we move on?
Can you stay on for a little longer?
Yeah. Okay, so let's do an example with a dictionary in a second. But remember, the two basic data structures that we've talked about so far have been lists. And lists, you can think back to COP2030. Those are going to be very similar to your arrays. We're still streaming here. Check on this every once in a while. So your lists are going to be very similar to arrays. Internally, they're a little bit different, but you don't have to worry about that too much. And it's when I have basically a list of values, all the grades in the class. Now we had another data structure that we introduced before called a dictionary. And dictionaries are nice because they're what's called key value pairs. So say, for example, in the case of the list, I really didn't know which grade belonged to which student. And that might be fine. I might not actually care. If I've got a bunch of, like, say, for example, 1 million data points from a sensor, like, I might not care what time of day it came from or whatever. I just want to know, like, the average temperature for the day, something like that. However, you might actually want to associate it with that somehow, what we call a key value pair. Because with the list, we could only use the number, and it just incremented. You went 0, 1, 2, 3, 4. It was just like we can't have 0, 5, 7, 11. You know what I mean? It has to go 0, 1, 2, 3, 4, and so on. But what's nice about a dictionary is with that key value pair, now I can associate it something like a name with that. And that becomes more useful because then if I wanted to still know the original, but then do something like calculate an average of the class, I could still do that. Okay, and you'll know during the application which you need. Okay, so what I want to do is an example of like a phone book, and that's actually a perfect example of when a list would be useless. If I just had a list of phone numbers, that'd essentially be useless, I think, to most people, right? Like, okay, I have phone numbers. What does that mean? But with the dictionary, what I can do is I can associate each person's name with a phone number. Okay, so that's the example I want to do now is a simple phone book. Can I switch over? Are you still?
Yeah, I'm done.
Okay. So let's do that. Let's make a open up another REPL. I'm just going to reuse this REPL, but open up another REPL, and then let's do a simple phone book. Now, if you remember, we did have the ability to dynamically add and remove things and set values and stuff. Just for today, for this example, just so we get a really good grasp on dictionaries, I'm just going to define my whole dictionary up front. Okay. So the idea is that it's going to be a name and then a phone number. And we're going to take this example kind of far. So let's do this. Okay, so the name is Alice. Does anybody know where this Alice, Bob, Charlie thing comes from? It's an old encryption thing that if you had Alice and Bob and they were trying to communicate. Yeah. And so that's why I always use this. I always have trouble thinking of names.
Wasn't it this scenario, Alice and Bob and Charlie? Wasn't it that scenario where RSA fingerprints were
Yeah, it was basically having to do with eavesdropping. That Alice and Bob are, I think it's Charlie or Charles or something like that.
Charlie's the hacker.
Okay, yeah. And then Charlie's trying to eavesdrop on Alice and Bob's conversation. Okay, but anyway, I don't actually know an Alice, Bob, and Charlie. That's so. I think it's just like a bunch of friends of mine. It's not. It's a historical thing. Okay, and then if we wanted to know Alice's phone number, what could we do? Well, if I wanted to print out Alice's phone number, walk me through that. So the dictionary that the variable I just called it D, or let's do this. Let's actually call it. I don't want to call it phone book because I want a directory. A directory is just basically like a lookup thing. You can look up phone numbers, emails, addresses. It's just what we call a directory. And so if I wanted to print Alice's phone number, I would do this. Like in the square bracket notation. And then to actually print it, just go ahead and surround it by a print. So we did that last time. Is everyone comfortable with that syntax? So let's actually take this a step further. We can actually put other dictionaries inside of dictionaries. So rather than just having the phone number, let's do this. Let's have their phone number and email. So to do that, rather than just putting a string, we can put in our curly braces here, and then we can have email, oops, I'm sorry, it's there's a colon separating it, and then we'll just say phone, oh, did it again, sorry, thinking lists. So we have our key value pair and then another key value pair. And so let's do the same thing for Bob. Bob's going to have an email, colon, and now if I try to, in the directory, print the entry for Alice, we're going to get the email and the phone. But what if I was just looking up the phone number? How would I find the phone number? I don't really care about the email. I just want to retrieve the phone number. How would I do that? Exactly. So this actually returned a dictionary. So now we can just say, okay, so this is going to return the dictionary for Alice, but then we're saying go inside of that dictionary, get the phone number, and then that'll just return that string. And I think I showed you last time the Twitter API, right? With the the very complex data structures that they have. So you'll get used to using these. This one's only 2 levels deep. This one's not particularly complicated. But let me, I don't want to get any more complicated since I'm just introducing dictionaries, but I just want to kind of, for you to think this through. A lot of people have multiple phone numbers. We could take this one step further and say, for example, you didn't care if it was their home or work or anything. You just wanted to know all their phone numbers. We could even do this. We could add. So don't add this. I don't want to make your life more complicated. But we could actually add a list of phone numbers as well. We can pretty much infinitely embed these lists, dictionaries, and other data structures as needed. I'm sure there's a limit. I say infinitely, but you know what I mean. Like we can very deeply come up with a very comprehensive directory where we've got emails and phones and addresses and multiple addresses. If you had a standalone application, you could potentially represent, you know, like for example, if you got a small company and it doesn't really warrant having an entire database, you could potentially represent your whole company in one of these data structures. It'd probably be a bad idea for many reasons. These storing your data like this gets very complicated very quickly, and it's hard to get, like, you can already see we're only 2 levels deep, and I'm sure already some people are like, you're looking at it and going, what's going on here? But so we tend not to, let me think how to say this. These data structures are good for data transfers, like if I'm sending, you know, data from one person to another. But if you have other long-term storage, we would probably just stick to a database. But anyway, these dictionaries though, this 2-level nested database, not database, this directory where we've got 2 levels of nesting. 2 levels is actually not that uncommon. 1 or 2 level dictionary, you're going to use these things constantly. Okay. So is everyone good with this example? I'm not going to get any more complicated today, but everyone understands this example at least. The most complicated we'll probably get by the end of the course is just, remember how I showed you if we wanted to add a list of phone numbers? That's probably about as complicated as we would get. And we could actually even expand this out even more. We could do something like this. I'm not going to do this. I'm going to revert this. But doing something like this might even make it even more readable. And then we put in, you know, some space between here, so you can see this is very clearly Alice and her email and phone. But we'll just leave it compact for now. Maybe in the next example. Okay. So I'm going to leave that. I do want to do one more thing. It's just kind of a random topic that we'll probably talk about by the end of the course. So let's open up one more REPL. And we did this before, I think, right, where we added a text file. So let's just add a text file. Let's call it test.txt. And it's not going to have anything particular interesting. It'll just say hello. So I went up here, added a text file. I have test.txt, and then main.py. Now, there's different types of errors and problems in your program. There's basic syntax errors. That's when, like, I forget a semicolon or a parenthesis or something like that. Those I can catch at compile time. When I actually compile the program, in this case, we don't really compile, but you get the idea. Then there's the idea of runtime. I can't really catch that error until I actually run the program. So early in the course, we read a text file. I don't know if that text file exists or not until I actually run the program. Does that make sense? So this is what's called a runtime issue. So let's do this. Let's say, for example, we try to open up a file. We said open test.txt, and we just did print f.read. I should just print hello. Now what happens if that file doesn't exist or we mistyped it or something else? We get something called an exception. File not found error. The idea is with an exception, we have our normal mode of processing, and then we have an exception. Well, the normal correct way the program would have run is that it would have opened up the text file, read the text file, and printed it to the screen. But we are running our code and we said, hey, something exceptional happened. I couldn't actually open that text file. We can't proceed forward until this is handled. Okay? And the way to handle these, we're not going to, maybe later on we'll create our own exceptions, but there's a lot of built-in exceptions to the language. So we have this very specific exception right here, file not found error. So what we do is we wrap our code block. We say, try to do the following. Try to run these 2 lines of code. Now, being an experienced Python programmer, I know that something might go wrong. That file might not exist. Somebody could have deleted the file. Just a million different things could happen. So what I say, okay, is if an exception occurred, I type in this special keyword, except. Now we can be very generic, and we can just say, okay, in all exceptions, because there's probably a bunch of different ways exceptions could happen here. Not just the file is missing. It could be that the system runs out of memory. Like a million different things could happen. This is the broadest. This is just saying if anything exceptional happens, but now that's probably a little bit too coarse. Like that's not fine-grained enough. Okay, something bad happened. What do I do with that? So what we can do is we can catch specific exceptions. In this case, file not found error. And then we know if we get this exception, then we know specifically that it was file not found error. There's a bunch of different errors and exceptions. But now we can give a more specific error message. Now sometimes these exceptions will actually give even more additional useful information, like a human readable string. And what we can do is we can say, okay, so go ahead and give me that information. File not found error. Is it as E or is it E? I think it's this. Hold on. Let's try this. I think it's the syntax. Oh, it's because E is not being used. Then we can just go ahead and print whatever human readable string that exception returned. We said, okay, the file was not found, and then the specific error message that the library returned was no such file or directory, and then it tells us the file name. Now, often in class, we have these very manufactured examples that I know are going to work correctly, so we don't use them. In the real world, you're going to have these exceptions occur all over the place. So it's going to actually be very, very common that we have try except blocks where we try to do some code. We know the different possible common things that can happen. We can handle those. In this case, if I were trying to, like, let's say, for example, I put a bunch of, like a password in a text file and I connect using that password or something like that. If I can't open that text file, I probably need to just exit the program. There's not much else I can do. Now, the last thing that we can do is we can do a catch-all for all other exceptions. Then we can go back to our something bad happened. And notice how it was able to catch that error specifically And only when something else weird happens, I can't even think of one off the top of my head. But say, for example, you're in a weird, like it runs out of memory, or there's a permissions error, something like that. Then it's going to drop out to that final exception block. Now you can create your own exceptions, but the general rule in Python is to try not to. In a lot of other languages, you see people creating exceptions all the time. I've noticed in general. Yeah, I mean, these are just in the standard library, but there's a lot others in other libraries that you can probably pull from. But this one's very common. Assertion error means that just there was some sort of some bad value or something like that. What else do I use a lot? I/O error. Anything related to like files or databases, you can raise those. Oh, this is one I actually raise a lot. Value error. That one actually, you gave some sort of invalid value. Like say for example, I've got a function that expects only positive numbers. Then value error would be something good to throw. Actually, this I would say a pretty good amount. So this says raised when the built-in function for a data type has, so the data is valid, but the arguments were somehow invalid. So it expected a number, which you passed it a number, but it was expecting a positive number. So it got data, it was just like not a good value, or maybe it was expecting some range of values. Okay. Be more than that. Anyway. So I think that's it for today. Any questions on anything we covered today? You're not going to have a specific assignment on exceptions, but we will probably in the future use them, and I might not explain them as thoroughly each time. Like the next time we use them, I might give you a quick reminder, but then after that, we'll probably just start using them just in regular code, okay? Okay, so next class, we'll do the review for the exam. I'll give you everything you need to know, just so you know it is a coding exam, but I'll give you everything you need to know to study for the exam. We're going to focus on assignments 2 and 3. Since assignment 4 is due today, actually, hold on. Let me think. Do this. Focus on 3 and 4. Assignment 2 is like a little bit too simplistic to give an exam question on. So focus on assignments number 3 and 4 and studying. But Monday, like I said, I'll give you a lot more details. So, yeah.
Is it a practical or?
It's going to be coding. So basically, you know how I could give you these assignments? What I'll basically do is like take assignment number 4 and slightly change it. Does it make sense? And you'd have to code that in class. So normally how you get to go home and work on your assignment and stuff, I would. So let me give you a good example of something I might change. So in this example, we had to find an average. What I might ask you to do is create a function which called min, which gives me back the smallest value found. And you'd have to do that as your exam. Does that make sense? So it's going to be like these two questions, but very, very slight variations. It's basically like I'm going to be asking, do you understand that basic assignment? And the other thing is that you can use your assignments and the class notes. It's just not, it's not open internet, but it is open, I guess you could say open notes. So any class examples that we've done, you're welcome to use. So that'll help too, okay? And what we'll do is on Monday, we'll go over these examples in like great detail. let me do this. Since we do have 15 minutes left, I realize some people are probably going to want to study for the weekend. Let me do this. Let me give you the details of how the exam is going to work, okay? So it's going to be 2 questions. It's going to be a coding exam. It's going to be very, very, very similar to how I give you your assignments. So if you've been doing okay on the assignments, you should be okay. Now, obviously, you have to do it on the school computers here during our hour and 15 minutes of class. You'll do it inside of REPL or whatever, you know, some people have other personal preferences, but you get the basic ideas that you'll actually be writing Python code. And it'll be 2 problems, but what I'll do is I'll take assignments 3 and 4, and I'll give you a slight variation. Like I already kind of named one where, okay, I know it's going to be based on a list. I know there's going to be some function involved. I just don't know what that function is supposed to do. So in your assignment, it was finding the average grade. But think about all the different variations I could do. I could find the highest grade, lowest grade, things like that, okay? But if you understand the core of the assignment, you should be good. Same thing with this. This was like a 2-part thing where first I found a value, then I had to modify the value. Think about the different variations I could do on that problem. So it's not like I'm going to make up some problem out of thin air. You're going to have your homework assignments as your guide. Now you can use any in-class things that we've done, like these little REPLs that we do in class. You can use any of those. I would suspect in general they're not going to be super helpful because, I mean, a lot of these you can see we've done a lot of random stuff that are going to have nothing to do with the exam questions. But what I would do is go through all your previous examples and find the examples that were very close to 3 and 4. Okay. The other thing is don't depend on, I think how to say this. I realize that a lot of you have all your examples saved inside of REPL. You might think, oh, I can just access those very quickly. I would highly suggest finding the closest examples to assignments number 3 and 4. And because we actually have, I think we have it installed. Hold on, let me find an actual text file. Because we actually have, no, we don't have Notepad++. I thought we did. Do you have to type it in and then?
Yeah, some computers have it.
Oh, okay. Yeah, so we have Notepad++, which is great because then what you can do is take these code examples, have Notepad++, and then while you're working on your exam, kind of have things side by side. Push this over a little bit. You probably don't need this as much. You probably don't need as much terminal area. Focus on your coding. And you'll have smaller fonts too, so you'll have a little bit more code to fit on there. Have things side by side. That way, as you're coding, you're like, ah, okay. You might want to have assignment number, you're like, okay, this question is very similar to assignment number 3. Let me pull up assignment number 3 over here and then start working on the question. The other thing I tell people to do is, hope it doesn't mess things up. Maybe also have the, thinking the best place to put it. Maybe you could just like put it on top somewhere like here. Just have the actual exam question available for reference somewhere nearby, okay? But anyway. Okay, so any questions on that? What we're going to do for the full review on Monday, what I'm going to do is I'm going to go through assignments 3 and 4, and we're just going to code the answer beginning and end for both of those assignments, and then we'll try little variations. I realize that that's not much time to give you to study, you know, between Monday and Wednesday, but you should, if you're going to study this weekend, really concentrate on 3 and 4. Don't just assume, oh, I'll have those available. You know, I don't really need to do anything with them. What I would actually study or to study, what I would do is just go back to 3 and 4 and try to redo those assignments from scratch without referencing your notes as much as possible. And only when you get completely stuck, reference your notes. That way, if you're like an expert on assignment number 3 and 4, when you get to your exam, you're just going to fly through it. If you're constantly having to refer to your notes, you might be a little bit slower. Okay? So any questions on the format or anything like that? Everyone's clear? Now, just to kind of like, just to let you know, in the past, most people get A's and B's. Now, they do study. Don't think it's easy or anything like that. I think most people do end up, studying and working hard. But don't think that this is like me setting everyone up for like a bunch of D's and F's. Most people in the past get A's, B's, and C's on these exams. Okay, so not a whole. Some people do obviously get D's and F's, but for the most part, the class average tends to be somewhere around like either a high B or a low A. Now, again, don't take that as I don't study. Just don't think I'm setting everybody up in here for like a D or anything. Okay. Okay, so if you have any questions, anything comes up between now and then, make sure to email me, and I'll try to answer your question as fast as possible. If there's nothing else, I guess I'll see everybody on Monday, and we'll concentrate on more reviewing on Monday, okay? And I'll post these examples in the video as soon as I can.